What we'll do finally then is just run through a non-parametric test when you've got a related design. So in this case, when you've got subjects which are taking part in all conditions, these are the non-parametric tests that you'll want to use. So this is equivalent to a related t-test or a repeated measures ANOVA. So we've got the following research scenario. Imagine a video games company. Let's call them Sony Soft to avoid any lawsuits. They wanted to investigate the effectiveness of different types of handheld controllers on how well people did on a video game. They had three types of controllers: the Evo Pro Technic, the ViperMax 3000, and the good old-fashioned joystick. They got 30 participants, and they got all participants this time to play a video game using each of the different types of controllers. This was counterbalanced to control for order effects. And the dependent variable was the level reached in a video game, which ranged from 1 to 20. Again, we've got ordinal data now. We can't be sure that the distances, if you like, between each of these levels is going to be the same in terms of difficulty. So what we've got this time is a related or within subjects design, one independent variable, this time with three conditions, and one dependent variable, which was the level reached in the video game. So what we use for this is a test that's known as Friedman's ANOVA. This is when you've got more than two groups in a related design. It's the related subjects equivalent to an ANOVA. And if you've got two groups, then you can use the same options in SPSS, and it will produce what's known as the Wilcoxon signed rank test for you. Likewise, if you've got an independent design with more than two groups, before we use the Mann-Whitney U test, and you can extend that to more than two groups, and then it will just conduct a Kruskal-Wallis test on that data for you. But we'll stick with the Friedman's ANOVA for this example. So in SPSS, I've got the data. You'll see because it's related or within subjects design, we've got three columns representing each of the conditions of the independent variable, just like we had before with related ANOVAs. So we can run this test now. These are the scores in terms of the level participants reached. Let's run the non-parametric test. We'll go over to related samples this time. Click on that. You'll see it brings up the same box as before. So what we'll do is click on fields. And what we can do is move all of these across now to the test fields box. And then we can click on run, which will bring up the output. Then, like with before, it just gives you the summary of the overall test. So we need to double click this box again. Then we get the extra bits of analysis up we need, and I'll just focus on the right-hand side this time. So we get the total sample size, which is 30, and the test statistic, which is now the Friedman's F statistic. So you'd report that here. The degrees of freedom, which is 2, and the p-value is here, and the p-value is less than 0.001. So we've got a significant difference between the three groups. But now what we need to do is some post hoc tests or pairwise comparisons to have a look at where the differences are. SPSS does this by default, but what it does is it hides it away in this option down here. So if you go down to view, at the moment it's on related samples test view. What you'll need to do is click on this option here. I'll just move that up a little bit so you can see. Yeah, so go down to this pairwise comparisons option here. Click on that. And what you'll see is it will produce, first of all, this plot, which I don't find particularly useful, so we'll ignore that. We'll get down to this table here. And we've got the post hoc comparisons now for each possible comparison we can make. The first one was the comparison between the joystick and the ViperMax. And the second one was between the joystick and the Evo Pro. The third one between the ViperMax and Evo Pro. You'll notice that it gives you two types of p-values, the significance and the adjusted significance. The adjusted significance is controlling for multiple comparisons, so it's made a correction to the p-value. So ideally, this is the one you want to be using. So we'll have a look at these now. The difference between Joystick and Viper Max was significant at p of 0.005. The difference between the Joystick and the Evo Pro was significant at less than 0.001. But the difference between the Viper Max and the Evo Pro wasn't significant. The p-value here was 0.660. So what we'll do now is just have a look at the median scores again to see what that actually represents. Back into the main SPSS table then, we'll go to Analyze, Descriptive Statistics and Explore. Now what we want this time is to put these conditions now into the dependent list box, and we can select OK. It then gives us the descriptive statistics. We can see that the median score for using the Evo Pro was 5. So people on average were getting to level 5 when they use this controller. For Viper Max, the median score was 4. So on average, they were getting to level 4 for this one. And for Joystick, the median was 1.5. So they're on average getting in between level 1 and level 2 using the good old-fashioned Joystick. And from the post hoc tests before, we can work out that the difference between the Joystick versus both the Viper Max and the Evo Pro was significant. But there was no significant difference between the Evo Pro and the Viper Max, in that although participants using the Evo Pro controller were doing slightly better, this wasn't statistically significant. Note that with a bigger sample, that might become statistically significant. And one of the problems with non-parametric tests is they do have less power to detect significant effects compared to parametric tests. So it might be an issue of power here that we're dealing with. Now, just finally going back to these post-hoc tests, you'll see that we've also got a standardized test statistic, which is also a Z-score for each of these. Now, what you can do, and you can do this with the Mann-Whitney U test that we looked at before, or you can look at these comparisons, you can use this Z-score to calculate an effect size. So if you wanted to do this, the method to do this is in the Andy Field book, because we haven't reported any effect sizes for these. And generally, you'd want to get into the habit of reporting effect sizes. So if you wanted to do that, then have a look in the non-parametric chapter of Andy Field, and it will go through how you calculate the effect sizes from these standardized statistics. But we'll leave it at there, and that means that you've got through, if you've done this, all of your practicals. Woo, well done. Now's the time for revising for the exam. Never mind. But hopefully you found these videos useful. Good luck with the exam in January. Make sure you take at least one day off over the holidays to relax. And I hope that it all goes well for next year. All right, thank you.